right, that's part C. Let's look at part D. Does the graph have y-axis symmetry, origin symmetry, or neither? Okay, now before I answer this question, I want to take a look at the graph. I want to see what it looks like. So I'm actually going to go and answer part E first. Graph the function. Now, you're probably going to get multiple choice here, but we're going to take what we learned from A, B, and C, and we're going to graph this function. In part A, we learned that this graph rises to the left and rises to the right. In part B, we learned that this graph has zeros at 0 and -4. Okay, that's my x-intercept. That's my x-axis, and this is my y-axis. And then in part B, we also learned that it's going to bounce off of both of these points. Okay, so it's either going to bounce off like this, or it's going to bounce off like this. Now, knowing that my graph rises to the left, I know that it's going to have to start coming down this way. And in that case, it's going to bounce off here, and it's also going to bounce off here. And then it's going to end up rising as it exits to the right. Now, part C, we learned that the y-intercept is 0, but guess what? We already have that point. So when you go looking for your graph, you're looking for one that looks like this. Now, part D, does the graph have y-axis symmetry, origin symmetry, or neither? Well, it's not symmetrical about the origin. Okay, remember the origin would take this, flip it over once, and then flip it down again. I don't even have anything down here, so I know it's not symmetrical about the origin. And y-axis symmetry means that it would flip over this axis right here. Okay, so does everything on the right look exactly the same as all of this on the left? No, it does not. So it doesn't have y-axis symmetry either. So does the graph have y-axis symmetry, origin symmetry, or neither? And the answer is neither. All right, that's our 5-point problem.